Today we're going to talk about the first lesson in Chapter 5, which is solving linear systems by graphing. We'll define what a linear system is and also talk about how to identify what the solution of that system looks like. A linear system, or a system of linear equations, is a group of linear equations, just like we've done in Chapter 4, and it has either two or more equations, and they both have x and y. The solution of the system is the ordered pair that makes both equations true. In this case, we're going to talk about three ways to solve them, and today the first way is to graph. Graphing a linear system is the least accurate way to find the solution of a linear system. In future lessons, we'll talk about how to solve a system using substitution and the other method, which is by combining or eliminating one of the variables. Today's lesson is simply by graphing, so we'll show you a couple of examples of how to do that. In example 1, we have two equations. They're both in slope-intercept form. We were going to use our coordinate plane here to create two lines, and to find the solution of that, we'll identify how to do that. So we're going to watch here as we graph these two lines. We identify the y-intercept, create 3 or 4 points, and then from there we're going to draw a line through those points to create one linear equation. We then use the second equation with the intercept of 2 and the 4 points, and we create our line there. The solution that we're talking about is the point at which the two lines intersect. In this case, the smiley face identifies the line where the point where they intersect, and now we're going to check that answer. The point that we identified was 2, 6. So we're going to substitute into the first equation the 2 and the 6 in the proper coordinates. -1 plus 7 equals 6, so that is true. In the second equation, we again substitute 2 and 6, and we create a correct solution, so our answer has been checked. Remember, as we talked about what the definition of a linear system and the solution is, it's the ordered pair that makes both equations true. In this case, if we go back, the point 2, 6, which is where the lines intersect, makes a true statement for both the first equation and for the second equation, even though you can't see the check mark behind. So because we checked it, we know that 2, 6 is the proper solution. Moving on, we have two separate equations, and again we're going to determine the point at which both of those lines intersects. Once we mark the point in the ordered pairs, we draw a line through. Same thing for the second equation. And finally, we identify the point at which they intersect. It appears to be that -1 is the solution. So we're going to do that and check it by plugging it into both of the equations. They both have to be true. And therefore, once we determine that it's a true statement, we can say check for that. And now we input it into the second equation. -3 times 1 is -3, plus 2 is -1, and so -1 equals -1. Therefore, our check over here is true, and our solution of the point 1, -1 is the solution for this linear system right here. If you have some graph paper, take it a second and try to find the solution for this system of linear equations. Hit pause and try to do that now. Hopefully, after you graph both equations, you found that the point at which they both intersect is 1, 3. If we plug them both in, we do get true statements, and therefore the check is there, and we have the point of the solution to the linear system. As we get a little bit more complicated, we're going to take an equation that's not in slope-intercept form, it's in standard form, and both of them are. Watch what we have to do here in order to find the solution of this linear system. First, we have to make it into slope-intercept form in order to graph it. And so we get y equals 3x plus negative 2. So we're going to go ahead and graph that line. Once we have that line graphed, we're going to go ahead and erase that part. We're going to subtract 8x from the second equation. I apologize for the overwriting. Your equation for the second one should be y equals 4x minus 3. You can see how the points could tend to get a little bit congested as you graph two lines. The point that it appears to be the solution is 1, 1. Now we have to check it. Plug it into the correct variable, even though they're both the same. 1 plus 4 times 1 minus 3 does in fact equal 1. And the second equation, the one that was up here, will now substitute in. Three times 1 is 3, 3 minus 2 is 1, and therefore we have 1 equals 1. Therefore our point there is the correct point of 1, 1. In your stained glass window project, you have these points where a lot of your lines intersect. For instance, up here at positive 12, on the x-axis at positive 8 and negative 8. You also have points down here at negative 12 where lines intersect. In the meantime, you also have points there and there. And this is what your graph should look like when you have your stained glass window project all created. So take your time when you do that and see if you can pick out the points where those lines do intersect, as we'll start to move into finding the solution for linear systems.